So let's take a look at this example where we're going to calculate the test statistic and p-value of a two-tailed test. So John claims his free throw shooting percentage is 85%, and to prove it he shoots 50 shots and makes 37 of them. So we have the hypotheses here that were created, and we know that p is 0.85 because he wants a shooting percentage, or his claim of a shooting percentage is 85%, and we're just trying to see is that right or wrong. So this is why we have a not equal sign. It's a two-sided test, so I don't care if he's too low or too high. And so, how do we find the test statistic for this? Well, using our formula, again, our test statistic is just going to be how far away as a z-score was our observed values going to be from what we expect, which is the 85%, assuming he's telling the truth. Well, that formula is just going to be p hat minus p naught, which is the p from our null hypothesis, over the square root of p naught q naught over n. So we have all the values here listed out. So our p hat would just be 0.74, which comes from the 37 successes out of the 50. What was our p naught? That was what we assumed, which is the 0.85. And then we have the standard divided by the standard deviation, which is 0.85 times 0.15 all over our sample size of 50 shots. At this point, we can just take our calculator and plug it right in. And we get negative 2.7183. So again, what does this value represent right here? This is how far away our observed data are from what we expected. We expected to see 85%. And our data shows that this was more than 2 standard deviations below what we expected, what his claim was. So that right there should already make us a little bit of suspicious about his claim. Like, something seems a little off. More than 2 standard deviations lower than what he said. So let's find out then the p-value. So we found how far it was, but how likely is it to get something that far away? How likely are this data to get something as extreme as this data, assuming his claim of 85% is true? Well, as we saw again, this is just a matter of finding our probability using the normal distribution. We expected to see something that was 85%, so that would be somewhere near the middle, but we got something that was 2.1783 standard deviations below the mean. 2.1783 standard deviations below the mean. One thing to think about though is, remember, this is a two-tailed test, meaning I want to see what's the probability of getting something that far away in either direction. So when we're finding the p-value of a two-sided test, we actually have to find the other side as well. Going that same distance away, 2.1783 standard deviations away, but this time, what if it was 2.1783 standard deviations too high? Then the right tail should also be part of this p-value, the probability of getting something as extreme as our observed data. So you're going to see that what we're going to do on our calculator is find the probability of one side, then we're just going to double it so we can have the probability of getting either side of this. So let's take a look at our calculator. So using art of stat, again, we are using the normal distribution. We're going to find our probability. We're trying to find the chances and leave it at a mean of 0 and 1 for the standard deviation, since these are z-scores. Now we can take that lower tail, the one we got, which is the negative 2.1783, and put that in. And it'll give us this probability, 1.469%. So we know the probability of getting something that far or less than it that gave us 1.469%. As we said though, this was only one side of the equation, so how do we find both? We just double it. Our p-value will just be that number, and we're going to double it. So times 2. And if we take that number times 2, it will give us our p-value, which in this case comes out to 2.938%. Or as a decimal, this would be 0.02938. So our p-value, this right here, is the chance or the likelihood of seeing our data if he was correct.